Okay, hi, and welcome to another installment of Math Basics with Mr. Besh. Today we translate graphs, and our spotlight is going to be on two graphs in particular, the stem and leaf plot and the box and whisker graph. I chose these for two reasons. Number one, they're probably the most unfamiliar to students in the 7th and 8th grade, and secondly, they're probably the most useful that you'll ever use. First one we're going to talk about is the stem and leaf graph. The stem and leaf graph is a plot composed of two columns, a tens column and a ones column every time. And what happens is you take the values in the tens column and put them together with the values in the ones column to make an actual piece of a value in your data set. So how you translate and read this, if I go in the first row, the numbers I have in the first row, underneath the tens I have a 0, underneath the ones I have 7 and 9. The first value in my data set, what I have to do is take the 0 from the tens column and put it together with the 7 in the ones column. When I put it together, I don't add them together. I just stick them together like a peanut butter and jelly sandwich. So now what I have is I have 0, 7, which represents 7. So the lowest score, the minimum of my data set, is going to be a 7. The next number in my data set, I take the 0 and the 9, put them together, and now the next smallest value in my data set is going to be 9. The next row below that, notice I'm going to take the 1 and the 6, put them together. That's going to make a 16. I actually have 3 of them, 16, 16, and 16. And then the last number in that row represents a 17. And I continue to do that all the way down until I get to the 6s in the tens column. And the last two values I have of my data set are 60 and 62. This is how you read a stem and leaf plot. Now, why is this so important? Obviously, I didn't say it was hard to do. Why this is so important is because when you do statistics and when we're doing our basic 8 calculations, the first thing you have to do is put your numbers in order from smallest to largest. And that's what the stem and leaf plot does. It's a graphic organizer that takes my data and organizes it from the min to the max. A great and useful tool when calculating data. And to prove this, I'm going to take this graph right now. I'm going to calculate my median the way it is, and then my first quartile, my third quartile. And I'm going to do this by method of counting back. I want you to watch what I have. So when I take a look at my data, remember the first thing that you always want to do is count your data that you have first. Then when you put it in order from smallest to largest, or when you put it into a graphic stem and leaf plot, count it again. Make sure that you have the correct number of data, because all it takes is one missing or one too many, and then it causes us to miss all of our questions. So now when I count my data, I got 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I got 20 pieces of data here in my stem and leaf plot. So when I count back to find the middle, and that's what I'm doing right now, notice I cross one out in the beginning, one out at the end, one out in the beginning, one out in the end, till I fight to get to the two values in the middle. And remember, I know there's going to be two values in the middle because there's an even number set of data. Now the numbers in the middle are not 4 and 5. It's 24 and 25. And when I find the median, I need to take the average of these guys. 24 plus 25, then divided by 2 gives me 24 and a half. Now that's my median of my set of data. Now remember what the median is. It's a place value. It says here is where you separate your data into two halves, a lower half and an upper half. Now remember our goal. Remember what we have to do. Once we take our data and separate it into two halves, we then need to find the first quartile or lower quartile, and then the third quartile or upper quartile. And what that is by definition, remember, is the median of the lower half of data and then the median of the upper half of data. So then I go back and I count the same way. I take the two terms that were in the middle in the lower half of data. And the lower half of data started at 7 and went all the way up to the second 24. The two values that were in the middle were a 16 and a 17. So again, I have to take the averages of those two. 16 plus 17 divided by 2 gives us 16 and a half. So now 16 and a half is my first or lower quartile. Then to do the same exact thing for finding my upper quartile or third quartile, starting with number 25 and going all the way up to 62, the two values that are in the middle are 38 and 42. Add them together, divide by 2, finding my mean of those values, I get 40. So now my third quartile or upper quartile comes out to be 40 in my data set. This is the stem and leaf plot. Very useful, very practical graphic organizer to take your numbers and put them in order from the min to the max. The second graph I want to look at is the box and whisker graph. Notice, box and whisker graph has a number line. The number line doesn't have to start with 0 and doesn't have to go up to 100 or 1,000. The number line needs to be very practical. It needs to actually show you my data, a simple basic range. What this data can be, and I'm going to use this example a couple times, but this data could be a test in math. And the test in math, basically the best score you could get on this test is 60 points, as you can see from my graph. And then the lowest score, obviously, a student could get a 0, but nobody got that. So what I did was, since nobody got below where you can see my min on my graph, and my min kind of looks like 22, all right, that might be the lowest score of the test that they had, okay? So now, when I make my number line, I don't have to go from one end to the other. I only have to go where my number line is as far as my biggest value and as far down below as my smallest value. That's all I have to do when I make my number line. Now, your number line can come below it. Your number line can come above it. That really doesn't matter. Now, every box and whisker graph is composed of 5 crucial points, 5 benchmarks, and these benchmarks are the following: the min, the first quartile, the median, the third quartile, and the max. The box in the middle is composed by sides, the first quartile and the third quartile. Every box in a box and whisker graph, the sides are made up of the first quartile and the third quartile. And the value in the box is always the median. Now notice, it does not have to be in the center of the box. It can be anywhere in that box. But every time in that box, you will see the median. Now from the sides of the box branch out the quote-unquote the whiskers. The whiskers go from the third quartile to the max, that is that upper whisker, and then you got one from the first quartile to the min. Okay, so now we got 5 very important values. If anybody ever says, what does the box and whisker graph give you a best picture of? You say it gives me a best picture of the median. Because here's what the box and whisker graph does. It takes our data from smallest to largest, and obviously if you got your data from smallest to largest, it represents the entire set of data, 100% of data. And the box and whisker graph breaks it down into 25%, quarters. So now, every single time on every single box and whisker graph, from the minimum to the first quartile will always be 25%. From the first quartile to the median will always be 25%. From the median to the third quartile will always be 25%. And last but not least, from the third quartile to the max, again, will be 25%. So when you travel from the min to the max, that represents 100%. Each of the whiskers are 25% apiece, and the box itself represents 50% of all the data. Now, I know students come up with a question, and it's a very good question. They say, well, I don't understand something, Mr. Besh. You see, from the minimum to the first quartile, the whisker is longer than the third quartile to the max. And you told us that they both represent 25%. Yes, they do. And there's a simple reason for that. And I'm going to use a small example. Let's say on this math test that was out of 60 points, 20 students were in the class that took it. 20 students. That means if I break those 20 students' scores down into quarters, okay, that means 5 of my students would fall between the minimum and the first quartile. That means 5 more students would fall between the first quartile and the median. 5 more students would fall between the median and the third quartile. And last but not least, 5 more students would fall between the third quartile and the max. The reason why the third quartile and the max is shorter than the min to the first quartile is because of those 5 students between the third quartile and the max. Their scores were close together. They might have had like a 60, 59, 58, all the way down. As we can see, the lowest score from third quartile to max was 55. But yet down below for the min to the first quartile, the min looks like a 22. The first quartile is 35. So those 5 scores, the difference between the first quartile and the minimum was 13 values. Okay? So now when your whisker is shorter or your values are shorter, that means that the scores in that group of that percentage were closer together rather than like the first quartile to the min, which the scores were further apart. they still represent the same group that you're comparing, the same percentage group. So now when you look at the box and whisker graph, the box and whisker graph gives you 100% of your values. And from the min to the max, that represents that 100%. Everything from the box, from the first quartile to the third quartile, always represents 50%, and each of the whiskers at the end are 25% apiece. This is a very useful piece of data representing in education in my classroom, because when I take a look at the box and whisker graph, I can see a great picture of how my classes are doing. Now, this is the box and whisker graph. So, this was translating graphs. Our spotlight, again, was a stem and leaf plot and a box and whisker. I hope you found this both helpful and informative.